Alright, so this is where we left off. We're finishing up 5.7, and we're just practicing verifying trig identities. We're using the double angle formulas, and it's up to you which double angle formulas you choose to use. For instance, just starting with that left side, which I would argue is definitely more complicated than the right side. The right side just is cotangent, cosine over sine. As I'm looking at the top, I would use the double angle formula there that you have 2 sine of x cosine of x. And in the denominator, maybe I'll just rewrite that as 1 minus. Now you have to strategically think of what's a good formula to use for cosine. So as I go back a few pages and I look at the 3 different formulas for cosine, I would probably use the 1 because I want to cancel out that 1. This is why I would choose this formula. I just want to get rid of that positive 1 that's in front. Well, by using 1 minus 2 sine squared, let me change colors. I can replace cosine of 2x with that 1 minus 2 sine squared. Now you could choose the other ones. It's just going to take you longer to get there. Because as I'm looking at this and I distribute this minus in here, the 1's cancel, and what I have, the 2 sine of x cosine of x is still okay. And on bottom, I end up with, again, distributing 2 sine squared of x. I'm just going to rewrite it as sine of x times sine of x to help you out, to recognize that the 2's will cancel, 1 of the sines will cancel, and I'm left with cosine over sine, which is just cotangent of x. So just like a methodical step-by-step process will get you there, but being strategic about it is very, very useful as well. So it's going to take practice. I knew how to do this. I've done lots of trig identity problems. I've been teaching pre-calc for years, so it made sense to me. And just so you know, we can use these double angle formulas to get even more complicated of things. For instance, I'm already giving you the answer here, so that shouldn't be the tricky thing. The tricky part is getting to that form. So I know in the past I keep saying to look at the more complicated thing first and then work backwards. In this rare instance, I would actually start with the easier thing. This is my opinion. Because I'm thinking about sine of 4x as sine of 2 times 2x. And the reason why I'm bringing that to your attention is because 2x is now the angle, and I'm doubling that. So if I go back to my formula sheet where it said sine of 2 theta, and it was 2 sine of theta cosine of theta, well, now my theta is that 2x piece. So instead of 2 sine theta cosine theta, it's 2 sine of 2x cosine of 2x. So now, let's just concentrate with one thing at a time. So, starting with, let me do this in green, the sine of 2x, that's another double angle formula, which would be 2 sine of x cosine of x. Well, now looking at cosine of 2x, remember I have a lot of different options for cosine of 2x. Let's use a drastically different color instead of slightly different. Well, let's look at our options. We're trying to get, as I'm looking at this, we're trying to get, cosines and cosines here. So maybe what I would do is rewrite cosine of 2x, and again, you have access to the formulas, is I'm going to strategically pick this one now, this orange one. Now you can pick these other 2, but I think the orange one is the way to go, because as I look at the final answer, I have a cosine cubed and then just a cosine here, which is pretty close to cosine squared minus 1. So that's what I'm going to do. 2 cosine squared of x minus 1 is equal to cosine of 2x. again, I just picked one of these three, but I strategically picked this one because it looked nicer for my final answer. So as I go back to that problem, sorry I keep going back and forth, what I'm also seeing is it looks like they're distributing. Let's go ahead and distribute that in there. Now I'm going to distribute both of these 2's and all of that. So 2 times 2 is really 4, times this 2 would be 8. There's sine of x, but then there's cosine cubed of x minus, let's see, 4 sine of x cosine of x. Oh man, I'm really close to this. Except it looks like they factored out a 4, and this becomes sine cubed of x times cosine of x. I think I hit a snag on what I should have done. Maybe what I should have done, and it's okay. Sometimes even being wrong will provide some insight. That maybe I shouldn't have strategically used this red one from earlier. What I should have done is used the one I typically use, which is cosine squared of x minus sine squared of x. Because I didn't notice the sine cubed earlier. So as I distribute, well, how about this? Because I don't think this has a factored out 4. I meant to switch back. So let's leave that 4 in front. 2 times 2 is 4. But let's only distribute the sine of x, cosine of x in there. Okay, well, sine of x doesn't have anything to multiply by this cosine. But cosine times cosine squared is cosine cubed of x. Okay, so sine times sine is, sorry, I said that wrong. Sine times sine squared is sine cubed of x. And then cosine of x. There we go. That's it. That's the one I should have used to get to the correct answer. And then a little trick there with factoring out a 2, but also distributing to get to that answer. So sorry I started to lead you down the wrong path, but that's okay. We still got to there. And this is one of the few times that I think starting with the easier problem actually makes this trig identity work. And there you go. So there is quite a bit of homework. There's a free response, and then 1 through 11, 12, 13 problems. So pretty lengthy homework, so you might want to get started on that.